happen? And what do you suppose we get when lithium replaces lithium chloride? Now, here's the $10 million question. Do I get this? Or do I get this? And I'll even put a little S there, solid. Do I get the metal or do I get the ion? Y'all say ion? Why? Back it up. Give me a reason. I don't know. I just think it probably ought to be the ion. Anybody have a reason for saying ion? Say both? No, pick one. Don't be that good. Give me a reason.
Because this experiment when you cover
No. All right, well, let's think.
Lithium is 1 plus chloride, chlorine is 2 minus, so
Continue.
1 plus in order to balance out.
What are we trying to balance out? There you go.
The lithium chloride.
As far as atoms go, it is balanced. I'm not following you. But, huh? Charge-wise. What are we thinking about charge-wise? What makes the charge? What makes the charge? What might we consider balancing here? When we're talking about oxidation and reduction, what are we talking about transfer of? Electrons. So I'm guessing to balance for electrons, one of these is right and one is wrong. Oh, really? Oh, let's analyze it. What's the oxidation state of this lithium? 0.
Oh yeah. Oh.
It's lithium metal,
Okay.
pure element. Okay. What's the potassium here?
1 plus.
1 plus. Chlorine is 1 minus. All right. What's lithium here? 1 plus. And the chlorine? 1 minus. So nothing's going on with the chlorine, is it? But lithium went from 0 to +1, so it lost an electron. Where might that electron go? It just disappeared? Where's it going to go? Where's it going to go?
Next to potassium.
Okay, so now you want to rethink your answer. Which one's right? Okay. That. It has to be that. So when you see a single replacement, where you have a metal, the pure element, not an ion, the pure element, replacing something in a compound, no, you're going to get a pure element, the metal on the other side, not the ion. Okay? And it should precipitate out. This happened, you'd start with lithium metal, it would replace the potassium in aqueous solution, and a different metal would precipitate out. Okay? Questions? Comments? Concerns? I have a concern.
What is it?
Well, my concern is, as a young AP pupil, you're not going to have access to the activity series of metals on an exam. And my students are notoriously lousy at memorizing stuff. I don't know why, but y'all are.
We should make them memorize all of that.
You want to memorize all that?
Memorize all of what?
You could make a song out of the activity series of metals.
No, we're not going to remember that.
I'll be no part of it, but you can. Get out your bestie.
Give me that cool
If you love something, say it true. It comes back to you. How's the rest of it? Sorry, Michelle? Huh? If it doesn't.
Well, then you're Alexis.
You did it.
to page 2 on your bestie,
No.
the standard reduction potentials in aqueous solution at 25 degrees Celsius page. We are going to learn to use that as a substitute for the activity series. Okay, we're going to do an example, and we're going to learn to use this to replace the activity series of metals to see if a reaction will occur. I just made something up and put it on the board for a single replacement. We've got potassium metal and copper 2 chloride. Okay? If the reaction does occur, what would we get?
Potassium chloride plus copper.
There's no calcium. KCl plus Cu metal. Okay? If it occurs, we'll get that. Now, we have 2 metals here. I want you to find them on your standard reduction potential table. We have 2 metals. Find the reduction reaction for these 2 metals on your standard reduction potential table.
Potassium, it says potassium plus E minus, right?
It's lithium.
Is it the bottom there?
We know the yeah.
We're not doing lithium.
I know,
Potassium.
I'm sorry.
2 up from there. Okay? And then copper, this is copper 2.
Plus 2 E
How do you know which one's which?
This is copper 2 plus, and it's going to 0. So we want that one. Where we have copper 2 plus going to the solid.
Oh, okay.
Okay? So that one's way up on the list up here, isn't it? Now, here's what I want you to do. Write them as they appear on this list, with the one that's on top, the one that's on bottom. So copper is on top, isn't it? So we're going to write that first, exactly as it appears on your table. Cu 2 plus 2E minus going to Cu solid. Right? Yeah. Now drop way down to the potassium and write it as it appears. K plus E minus goes to K solid. Okay? We have the reductions of both of these elements on the board. Now we're going to do a crisscross. Take a look at the bottom one. Everything that's on this side on the bottom, right over there. And everything that's on the bottom on this side, right on this side of the equation. So we're going to rewrite this. I'll rewrite it down below. Okay? We're going to have potassium solid on the reactant side now.
I'll give it to you tomorrow.
Now, don't get hung up on the electrons. We can always balance for electrons. But does this match this? Don't get hung up on the electrons. In fact, let's just take them out. We can always balance for electrons. That's not a big deal. What is it that doesn't match?
CL.
Okay, Cl is a spectator on both sides. Both of these are soluble. I don't care about spectators, so don't worry about it. Does everything that's actually participating in a net ionic equation appear as it should?
Yes.
What doesn't? Here I have potassium solid. Here I have potassium solid, the metal. It's not an ion, there's no charge. Sorry. Here I have copper 2 plus. Is this not copper 2 plus? Yeah, this is highly soluble. Maybe it would have been better if we'd written the ionic, but this matches. This is soluble. We're actually going to get copper 2+ ions in solution. Here we have the potassium ion. What would we have here? Potassium ion, highly soluble. So the ion is going to be in solution. Do we have copper solid being formed? We sure do. This matches. If you can do this crisscross thing, writing them as they appear on the reduction potential table, and then taking the bottom one and crisscrossing, if it matches the reaction as written, then it will occur spontaneously. That reaction will happen without any help. Okay? Later on in the year, when we get to thermodynamics, we'll be able to do some math and figure out what reactions will occur and explain why mathematically. But for right now, this is a quick little thing you can do to see if a reaction will occur. Okay?
The electrons don't matter?
Say again?
The electrons don't matter?
We can always balance for electrons. Yes, electrons matter, but my question here was, will this reaction happen? Will it occur? Now, we can always hook it up to a source of electricity and force the reverse reaction to happen. Actually, force electrons through it and make the reverse reaction happen, but that wouldn't be spontaneous. The forward reaction, as written there, will occur spontaneously. All right, one more thing. We're going to do something, and then I'm going to test it and see if you're right. No, I'm not going to blow anything up. All right, you can take a piece of zinc, put it in hydrochloric acid, and what do you think we would get from it? If the reaction occurs, what would we get? Zinc is 2+, and go, you haven't been paying attention. What am I going to get from that? H2. This is the positive ion in the hydrochloric acid. The zinc is going to replace it. The zinc is going from 0 to 2+, so it's losing electrons. Those electrons got to go somewhere. So the hydrogen ion is going to pick them up, and we get the diatomic hydrogen gas. So if this happens, we should see bubbles. This will be aqueous. This is aqueous. And this will be solid. Okay? We're also going to do it with copper. Solid plus HCl. What are we going to get from this? Say we get copper 2. Cu, Cl2 plus hydrogen gas. All right, who would like to come to the board and write those as they appear? Write the zinc and the hydrogen as they appear on your table. Somebody else can come and write the copper and the hydrogen as they appear on the table. We can do the crisscross, and let's see if these reactions occur spontaneously. Annalena, come on up. You want to do green or you want black? Where are you going? You do this one. Why not? What's the matter?
This one, huh?
Okay, well, perfect. Then you're the perfect victim. Okay, find zinc